Okay, in this video we're going to touch on some additional components that we see on an isokinetic report relating to work and power. Now remember that this is angular work and angular power. So in this case the work that we are referring to, for example here with max repetition total work, is measured by multiplying the torque that is produced by the athlete by the angular displacement that is achieved. That is the range of motion effectively down here, and the torque that is produced here. Now you may sometimes see or hear or read work referred to as the area underneath the curve. Now this is angular impulse when we think of torque multiplied by time. However, when people say, oh, it's the area underneath the curve, that is if the positioning, i.e. the range of motion, is also presented on the alternative y-axis over here. So if, as you see on the dynamometer screen when we're performing a test, you see just a torque time graph, that is angular impulse. However, if you also have position factored in, then depending on which unit you want to multiply torque by, be it time for angular impulse or the position, the range of motion for work, then yes, this can be defined as the area under the curve, but it depends what you're multiplying the torque by. Just to clear that up in case there's any confusion. Like linear work, angular torque work is measured in joules, and we have various different measurements which are presented here. We have maximum rep total work, we have the max work repetition, work divided by body weight, also then reported as a percentage, the total work that is performed across the set, work within the first third of the set, within the last third of the set, work fatigue, and finally average angular power, which is the work performed divided by the time that it took to perform that work. So I'm just going to delete some of these measurements that we're not interested in. Okay, so let's start with these first two, max repetition total work and max work repetition. So if we start with max work repetition, this tells us the repetition at which the maximum work that was done was achieved. So for this report we see that it's repetition 4. So this was a 360-degree isokinetic test in which the participant performed 10 repetitions. So max work was achieved on repetition 4, repetition 3, here for the left leg both during extension, and for flexion it was repetition 3 here and repetition 7. So first and foremost, this can be used as an assessment of the reliability of the test and as a hallmark of whether the participant or the athlete performed a relevant familiarization session. This is more relevant with higher repetition tests that are performed. People often incorrectly point out that or suggest that max work repetition is more relevant to higher angular velocities, which isn't strictly true. It's the number of repetitions that are performed. You could, I wouldn't recommend it, but you could perform a 60 per second angular velocity and perform 10 repetitions if you so wished. So it's not the number of, it's not the angular velocity, but it's the number of repetitions which this is really relevant for. So with higher repetition tests, like the one we have here, we place more weight on the max work repetition. Now ideally this should be repetition 1 or 2 at the highest. If we start to see the max work repetition being anything higher than repetition 1 or 2, particularly in this case where we see a 7, which is particularly worrying. So we'll highlight that in red just to stress our concern. This suggests that the repetitions preceding this weren't maximal effort. And that's really what you can think of total work as, the effort that's put in. So realistically, that should be the first repetition or two. Ideally, the first one. And the more repetitions you perform, the higher the max work repetition, the more unlikely it was that the previous repetitions were at a maximal effort. This is a hallmark, as with everything that we're going to discuss here with relation to work and power, of fatigue, again, which is why it's more relevant with a higher repetition number. So what this is basically saying to us is that anything prior to the repetition that we have highlighted here for max work repetition, anything prior to this can kind of be discredited because the athlete wasn't trying as hard as they could. So if you've got a 10 repetition test for the left leg when performing flexion of the involved limb, if we're seeing the max work repetition as being number 7, well, this just suggests that the first 6 weren't to a maximal effort. This is in a healthy athlete where everything is otherwise fine, of course. If there's any pre-existing injury, then of course this would be different. But as with all our videos, we're assuming in this case that everything is okay and we have a perfectly healthy athlete. So use this, if anything, as a hallmark of the validity of the test. And you want to see symmetry between legs, so they should occur within a repetition of each other, and ideally they should be on repetitions, ideally 1, if not 2. And the lower the number of repetitions that are performed, obviously, the more you want that value to be nearer 1. Okay, so the max repetition total work, that is saying, okay, on this repetition 4, what was the work that was performed? So in this case it was, just change color again, 165.5 joules, and on repetition 3 we have 164.5. So in many ways, people argue that this is more relevant than peak torque, which it is, because it gives us a better idea of the athlete's strength over the entire arc of motion, or throughout the entire range of motion, because work factors in not only the strength but the range of motion that was performed. So in many ways we can think of this as a more reliable measurement than peak torque, because we are factoring in the range of motion, so throughout the entirety of the range of motion. In many ways it's like doing a basic curve analysis. Once you've completed the test and you get the raw data, which we somewhat see here, it's the equivalent of looking at these curves and saying, right, let's look at the whole thing, whereas peak torque just gives you the maximal value that was produced. The work to body weight ratio, again represented as a percentage, much like the peak torque to body weight ratio, has similar implications to peak torque to body weight. Total work is a more interesting measurement in that it gives us the overall work performed for that movement across each repetition, which again gives us more of an idea of fatigue and how the athlete is performing over a longer period of time. So as with all of these work related measurements, they are more relevant with a higher repetition range. So you will expect to see total work increase as the number of repetitions increases, which is typically associated with an increase in the angular velocity. Where this comes into its own is when we compare work fatigue. Work fatigue represents the difference between work performed in the first third of the set and the last third of the set. So showing a nice measurement of overall fatigue from the beginning and the end of the set. Now, if, for example, just to highlight the relevance of this, you have a set that contains only 3 repetitions, then work in the first third is going to be the first rep, versus the third repetition and the difference between those, which again is going to be of less relevance than if you have a higher repetition set. So for any test that is 180 degrees per second with a higher repetition range, so sort of 5+ repetitions, this starts to become more and more relevant. This is where we really want to look for symmetry between the left and the right limb, as we do with all of these tests, but a bilateral difference here in work fatigue suggests that there is an issue with fatigue more in one limb more so than the other. The work fatigue can also give you another indication of the quality of the test that was performed. So anytime you see a negative value, such as here on the right limb during flexion, this starts to give us a bit of a red flag here. Because we have a negative value, this is telling us that actually there was less work performed in the first third of the test. So you see we have a work in the first third of 220, we'll just round down, joules of work performed, whereas in the last third we had 244 if we're rounding up. So suggesting that this athlete during flexion performed better in the last third of the set than in the first third of the set. Now again, it's possible that this could be due to injury, could be due to discomfort, but it is more likely with such a consistent value seen everywhere else that this was simply a lack of familiarization. So here we see in extension on both legs, we see that more work was performed in the first third versus the last third, and again the same here, and you can compare this with the other angular velocities. If you see a similar trend across other tests performed at other angular velocities, then yes, this starts to suggest to us that this could genuinely be a true result. But if it's a one-off, then it's more likely to be an anomaly. And if we also see a higher coefficient of variance, this isn't a terrible coefficient of variance, but it is on the higher side, and it's certainly the highest value of the four movements that were tested here. This would lead me to believe that perhaps this isn't the most reliable of results. Finally then, average power. So again, this is angular power. This is going to be the angular work divided by the time that was taken to perform this test. You can also calculate angular power by the torque multiplied by the angular velocity. You'll get the same value, but Biodex, as far as I'm aware, divide work by time to get this value. Average power is measured in watts. Excuse me. It likewise with work is able to give us an estimate of muscle fatigue. You would expect to see this increase as the angular velocity increases, and it can be a nice measure of functional performance, particularly after conditions like ACL injury. But again, it's grouped within this category of work-based measurements.